Hi, welcome to a2zknowledge.com. Today we are going to discuss about uh, Apache Flink with word count program as an example. If you see in big data, we have so many processing frameworks like Flink, Hadoop, in Hadoop MapReduce, and Spark, Storm. And if you go for any of these big data processing framework, the traditional example for the starters is word count, like how we have Hello World in programming languages. So similar to that, in big data environment, people used to go with this word count example. So Flink supports Scala and Python API. You can do coding in Python or Scala. It's up to you. But I'm going to show you a Scala example of word count in Flink. And I'm going to run this program in shell, in Flink Scala shell, but not through Eclipse or IntelliJ, but that is my next video. As a prerequisite, what you need to know is very basic Scala knowledge is required for now, but going forward, you need to know a lot. If you're going to code in Python, then you need to know Python. So here I have already shared my Scala playlist. So I also do Scala videos as well. I have shared that playlist link in the description box, so you can go ahead and see my Scala videos also. And also my Flink playlist link is also provided in the description box. Now we can get into the code. So if you see here, I have so this code is available in the Flink official website itself. So I've just did a copy paste from there, and you can see I'm starting with val text equal to. So if you are already a Spark developer and you used to do code with Java, then this syntax will be, sorry, if you do code with Scala or Python, this syntax will be very familiar for you. But for the others, I'm just telling you the val is a keyword val where are two keywords which we use in front of variables and functions. So it's I have also provided this in my Scala videos as well. So now I'm just creating val text equal. It's like creating an assignment, like a function or a variable assignment. Now I'm just starting with the BENV. B full form is batch. So in Flink, you can do both batch and stream processing, whereas B is batch environment dot from elements. So here if you see, I'm just giving some hard-coded values, the words, and this words has different delimiters. You can see comma, you can see space, and you can see some other special characters. So now you have to fetch all the words and then you have to group it, then you need to count the words. Now the next line is I'm just creating another function or a kind of a variable val count equal to text dot flat map. So the text is nothing but the elements that I feed it manually, and I'm converting that to as a flat map. And even flat map is again a Scala syntax that, again, like it's like a key value pair, but it splits all the words based on the delimiter. It will split the content. So that's what flat map used to do. And now I'm converting all the content of all these content into lowercase, and I'm split by like w plus. So this means like it will consider all the delimiters as a split by. Okay, it use split by with all the delimiters, because if all these words are being delimited only by comma, then it's fine. But I'm having multiple delimiters, so I just need to consider all the delimiters as a all the characters as a delimiter. So I give w plus. Now what I'm gonna do is I will just run till here. So before that, we can load the element. Okay, so I just need to start my Scala shell. And already my Flink is running actually. Maybe I can show you that as well. So my process is running JPS. Yeah, Flink process is running. To start Flink, like you have to give bin slash start hyphen cluster data sh, which will start your Flink process, and then you can start the shell. And you can see here BENV, as I told you, batch ENV. And if you are going to do some stream processing codings, you have to do SENV. So that's what we have done actually. Now I'm just loading this. Okay, it just got loaded. Now what I'm going to do, I'm going to run till here, just just for your understanding, I'm just running the code step by step. Okay, now you can see, as I told you, it will just split the word. So now we did some transformations, right? So first we are reading the data as one transformation, and then we are doing a flat map transformation and split by transformation, right? So these are some transformations. Now just to see the output, you have to perform some actions. Okay, so the syntax, the functions, that the predefined functions that you use in, even in Scala, means even in Spark, we used to do the same actually, and similar to Flink again. So the predefined functions has been splitted into two: transformations and then actions. So transformation is something by seeing the syntax you can easily able to understand this is transformation and this is action. So some people used to ask me, based on what I can split the syntax by seeing the flat map, how can I understand its transformation? Basically, flat map or split by or a list or whatever that is used mainly for transformations, right? Data transformation. What do you mean by action? Okay, the transformation is done. I want to perform an action, like I just need to print the result, or I need to collect the result, or I need to write the result into a file. So by seeing the syntax, you can say whether it is a transformation command or action command. Now what I am going to do is I'm going to perform an action called print. So that means I'm going to get the output. So Flink and Spark and all, like, it comes under lazy evaluation, and even Scala is a lazy evaluation. That means you are writing some 100 lines of a code by using a lot of transformations, but when there is no action in your code, your Flink or your Spark will not start the execution until there is an action performed in the code, because it's waste of energy, right? So I run all the code transformation, but finally there is no action required. Then why should I have to start my functionality? That's how Flink and Spark has been designed. We call that as a lazy evaluation actually. Now counts.print. So now you can see the result. So what it will do, it just splitted the words based on the W plus is like different characters as a delimiter it considered, and then it's just splitted the words. Now again, what is the next line? So map, I'm converting the output of the split by into map. That means key value pair. And the output of this split by will be the key. That means your words is a key. So that's the reason I just gave underscore here. And then I'm hard coding the value as 1. So I will just run till here so that by seeing the output you will understand output. Okay, I'll just paste this, enter. Yeah. Okay, now again I'm gonna do counts.print. Now you can see key value pair. So each and every word, comma 1. And you can see some repetitive words I'm gonna take, for example, the. So you can see there is like I will be having 3 times the word will be there. Okay, so here this is 1 time the comma 1, and then we will be having one more. Yeah, here it is, and there will be another one. So that means I'm not getting output as the comma 3. I'm just still I didn't do the sum operation. I'm just doing the map. So the comma 1. So the final thing is, if you see here, group by. Okay. Now imagine I'm having the comma 1, the comma 1, and the comma 1, where the is key and 1 is value, and I'm doing a group by of 0. It's denoting the position. So this column is 0 and the value column is 1. Okay. So that means group by 0 means you are grouping the key but not the value. So the output of group will be 1 comma 1 comma 1. So this will be the output of group by 0. Okay, so now then you are doing sum of 1. 1 denotes the position again. So key that is 0, and once this list of 1 is value. So sum of 1 means you are going to do sum of all these numbers, 1 plus 1 plus 1. So the output will be the comma 3. Okay, so now we run the whole command. Now counts.print. Yeah. So you got the output. So you can see here the 3 times, and we have a word 2 for 4 times, and there is a some letter E is just 1 time. So I'm just doing the word count here. Right. So now, like, this is the end of the video, and means sorry, end of the practical, and you can see the web UI of Flink, which runs in 8081 by default, and you can see like what are all the jobs that we have executed. So we are in the overview page. You can go for the completed jobs. I see these many jobs I have executed, and the duration you can see, and then total number of tasks that has been got created. So for our exercise, maybe let me refresh this. So for our exercise, uh, 3 tasks has been assigned and 3 tasks has been completed, and it's in finished state. Now I am gonna click this. You can see like so the data source and the flat map, which is as a first transformation, and then sum is a second transformation, and finally I'm doing a print, which is an action, is the final data sync. So this we call it as a DAG, direct acyclic graph, the representation of the plan of your execution, the code. Now coming down to this, you can see the status, bytes received and records received, and total number of tasks. So for reduce sum, one task has been assigned, so out of three tasks. And for reading the data and converting it as to flat map, one task. And then you have data sync, the last collect, the print statement, what we have done is in another one task. So you can ask me, how can I increase the task? So that is something, well, let's see how to increase the parallelism in my upcoming video. But for now, we are just going with the default one, what it has. So that's all with respect to the video, but I'm gonna explain a lot of concepts in Flink in my upcoming videos, and please do subscribe my channel and forward this to your friends and colleague. And I do videos in two languages, English and Tamil, and we have a lot of other tech videos. You can go ahead to my channel and explore, and I have shared my LinkedIn and Instagram URL in the description box if you want to follow me, or if you want to connect through, if you want to communicate with me, you can connect via those two mediums. Thanks for watching A2Z Knowledge.com.